Sir, Jai Prakash, sir.
Good evening, ma'am. I'm online, ma'am. Just
Sir,
now
good
students
evening,
are
sir.
joining. We will wait for a couple of minutes, ma'am.
Yeah, sure, sir. Sure, sir. Sure,
Yeah,
sir.
ma'am.
Thank you, sir.
Ma'am, shall we start, ma'am?
Sir, sure, sir.
Yeah. Tarun, you can start, ma'am.
Good evening, everyone. I honor it is a great pleasure and enthusiasm that I welcome you all to the Contextual Enhancement Webinar 2025. This event is designed for only second years B.Tech EC students of Kalasalingam Academic and Research Education. It is an unique opportunity to delve into the fundamental principles of engineering electromagnetics, covering the journey from Coulomb to Maxwell. We are honored to have Ms. Sandhya J. M.E. Ph.D. as our distinguished speaker, who will guide us through the core laws and concepts of this essential subject. A special thanks to our estimated chief partners and conferences coordinators and student organizers, whose efforts had made this insightful session possible. Their dedication to forecasting knowledge and academic excellence is truly fundamental. I encourage all participants to make the most of the session, engage actively, ask questions, and enrich your understanding of the subject. Good evening, ma'am. Very heartily welcome to this session, ma'am.
Thank you, sir.
Ms.
Thank you.
Sandhya J is dedicated academician and researcher specialization in RF and antenna design, currently serving as an assistant professor technologies, electromagnetics, and signal processing. She earned her BE in Electronics and Communication Engineering from Savita Engineering College in 2018, followed by an ME in Wireless Technologies from MIT Anna University in 2020. She is presently pursuing her PhD in antenna design, further advancing her experience in this field. Within the teaching experience, Ms. Sandhya actively contributed to the academia through
Tarun, are you on network?
yes, sir.
Okay, proceed.
Ms. Sandhya possesses strong technical experience in CST and ADS software, which she utilizes for designing micropatch antenna and math material antennas. Her specialization in electromagnetic simulations, RF circuit design, and wireless communication has her as a leading academic in her field. Additionally, she holds professional memberships in estimated organizations such as IEEE Signal Processing Society, IEEE Antenna and Propagation Society, IEEE Robotics and Automation Society, and IEEE in Electromagnetic Compatibility Society, among others. Beyond her research and teaching, she has been recognized for her exponential mentorship and student guidance. She has played a significant role in organizing key technical events, including IEEE SPS Seasonal School on Optical Signal Processing, and has conducted webinars on antenna concepts IoT applications, and signal processing technologies. She has also completed multiple NPTEL certificates in areas such as electromagnetic waves, Industry 4.0, IoT, and photonic integrated circuits. Ms. Sandhya's contribution extended beyond the classroom, as she also participated in Gimmunius Record events for engineering innovations and has undergone industrial training at ISRO, BSNL, Tracro Cable, and Keltron. Her commitment to academic excellence, research, and innovation makes her an invaluable assist to engineering community. Heartily welcome, ma'am. Let us start, ma'am.
Yes, thank you
Ma'am,
so
the session
much.
is now yours.
So thank you, sir. Sir, is my screen visible, sir?
Yeah, ma'am, your screen is visible now. Completely full screen is visible.
Sir, shall I start, sir?
Sure, ma'am, you can start, ma'am.
Yeah, thank you, sir. Thank you. So before starting my presentation, I would like to thank Head of the Department and Jai Prakash, sir, for giving me this opportunity. So today I'm going to explain about an electromagnetics. So from Coulomb's law to Maxwell. So I hope today's session will be a kickstart for the students to select electromagnetics domain as their future and also as the career perspective. So we'll start with the topics. So these are all the contents which I'm going to concentrate with. So first, basically, I will cover all the basic parameters and some of the basic contents on electromagnetics. So because before going into the laws, we must know how the laws are framed. So for that, we need to have some knowledge on some of the basic parameters and basic contents on electromagnetics, basic topics on electromagnetics. So first, I'll be covering on the topics like that. So first I'll start off with what is a field and what is an electric field and magnetic field, which is very, very important on electromagnetism. So without knowing the knowledge on what is electric field and magnetic field, we cannot understand the laws on electromagnetics. So I will be giving some points and some insight on what is electric field versus magnetic field, and followed by that what is electromagnetic field and what is electromagnetism and its model, and what are all the units and constants available in electromagnetism. Followed by that, what is a coordinate system and what is gradient, divergence, and curl. And followed by that, I'm going to start off with a theorem, that is Stokes theorem, Coulomb's law, Gauss law, and magnetostatics, Lorentz force, Biot-Savart law, Ampere's law, and what is inductance with capacitance, which plays a major role in electric and magnetic field, and what is time varying field, and what is Maxwell's equation, and what are all the boundary conditions we have to follow while using these equations. So the 1 hour session will be very clear cut on the basics of electromagnetics, starting from some of the basic contents, followed by the laws, and finally the boundary conditions. That is implementation. So first we'll see what is a field. So we all know a field is nothing but a spatial distribution of a quantity, either scalar or vector. So spatial distribution is nothing but something, it is scattered in space. So that's what we call it as a spatial distribution. So field is nothing but it's a spatial distribution of a quantity. Either it can be a scalar or vector. So we know the meaning of scalar and vector. I will just brush it up. So scalar is nothing but it's we'll dealing with only the magnitude part, and vector we'll dealing with both the magnitude and direction part. So you can refer the diagram here. So here scalar, under scalar quantities, the examples are speed, mass, volume, time, etc. And in vector, we'll going to have direction aspects also. We'll be considering the direction aspects also. So we'll consider some examples like velocity, weight, friction, etc. So on the whole, I'm going to make it clear that when an event in one place has an effect on something at a different location, we talk about that event as being connected by the field. So that's what is a field about. So spatial distribution of quantity is nothing but it's a technical meaning. So what is actually a field is that when some event is taking place in one place, that event's effect will be experienced on the different location. So that we'll term it as a field. So when you consider this right hand side diagram, you can see the transmitter and receivers are connected by a field. For example, when the base stations are located in some other place, we will be experiencing the communication and enjoying our communication in the different fields. So that is the event is connected by the field. So that's what is called as a field. So I hope we got some ideas on what is a field and how it can be. So it can be scalar or it can be a vector component as well. So next one is, what is electric field versus magnetic field? So electric fields are generated around the particles that bear electric charge, and magnetic field is created around the magnet when any force are exerted. So that is called as a magnetic field. So on the whole, we can say that electric field and magnetic field both are invisible forces. So but electric field is an invisible forces caused by the electric charge, and magnetic field is an invisible forces which is generated by the magnetic components such as magnets, etc. So both are perpendicular to each other. So this concept you have to be very clear. So electric field and magnetic fields will be perpendicular to each other. So when you change uh, uh, when you change the electric field, it causes the changes in the magnetic field. So both are perpendicular to each other. So the presence and strength of the magnetic field is denoted by the flux lines. So flux lines is nothing but the rate of magnetic fields. The rate and amount of magnetic fields around the particular area is called as the flux lines. Okay, so these are all the difference between electric field and magnetic field. So when one particular field experiences electric field and a magnetic field, oscillations will be produced. So that oscillations will be propagated in the field, which gives rise to electromagnetic field. Okay, you have to connect the concepts. So we are going to have an electric field as well as the magnetic field in a particular area. So oscillations will be produced, which will propagate in the field, which is called as which gives rise to the electromagnetic field. So electromagnetics is the study of charge at rest and in motion as well. So in rest also we are going to experience some electromagnetics behavior, and in motion also we are going to experience the same. So it is going to be the function of position and time. So this means that at places it's going to change. So we can have the functions of positions as well as time. So time to time it's going to change. So that's what this electromagnetic field is. So we are going to experience both the electric field and magnetic fields. So sources of electromagnetic field is electricity. So the electricity is going to be the primary sources for the electric field. So all the living things are subjecting to more radiations than 50 years ago. So nowadays we are experiencing a high percentage of radiations. Every gadgets we use, so every gadgets we carry is going to radiate. Every components, every devices which we are using at home and which we are using at the uh, educational institutions, at hospitals, at theaters, everything is going to is radiating. So we are all the living things are subjecting for more radiations than when compared to before 50 years ago. So we have to be very careful in such aspects. And next one is, what is electromagnetism and its model? So before anything comes into action, we have to create a model, then only we have to project it in the field. So for that, two approaches are there in the development of the scientific objects. So one is inductive approach and another one is detective approach. So inductive approach is nothing but we are going to take the measurement of the parameters. Okay, clear cut. So inductive is nothing but we are going to make the measurement of parameters. And detective approach is nothing but we are going to use the theories, and we are going to use some laws, and we are going to derive some relationships and map it. So that's what is the two approaches where we are going to consider to create a model. So there are three essential steps for building the model as well. So you can see the tableau column in the bottom side. So in the field theory, you just see, so basic quantities are we are going to consider the sources and field quantities, rules of operations, vector algebra, vector calculus, partial differential equations, etc. So to we are going to see many laws in the upcoming slides. So when you consider any law, we will do many derivations. So when you do many derivations, we have to infuse some basic rules of operations in it. Without basic rules of operations, we cannot derive any concepts in laws of electromagnetics. So that's why every semester you will be having some mathematic subjects. So we may all think, so why mathematics subjects are very, very important for ECE? So this is the thing. So for any subject under RF or under electromagnetism, we will be deriving the derivations according to only some mathematic concepts like vector algebra, vector calculus, partial differential equations. We will do integration, we will do differentiation, we will be summing up, we will be dividing. So all kinds of mathematical operations will be included in our derivations. So mathematics is very important for electromagnetism. Keep it in mind. Refresh the concepts before going into the subject. So third step is fundamental relations, that is electrostatic field, magnetostatic field, electromagnetic field. So electrostatic field is nothing but we are going to deal with the stationary charges, static. So that's the meaning of stationary. Magnetostatic field is nothing but we are going to deal with a steady current. And electromagnetic field, we are going to deal with a time varying field. So time to time, at position to position, it's going to change. So electromagnetic field relations will be connected to the time varying fields. And next slide will be on electromagnetic model. Okay, so we have created a model. So next, we have studied what are all the quantities we must follow for creating a model. Now, what are all the field quantities we must follow? So number one, electric field intensity, electric flux density, magnetic field intensity, magnetic flux density. These are the four field quantities which will be revolving around the electromagnetic domain. So make it clear. So whatever question you have framed or you have asked about electromagnetism will be revolving around these four field quantities for sure. So electric field intensity is nothing but the strength of the electric field around the source or around the point is called as electric field intensity. Okay, and its symbol is capital E. So make it clear. And electric flux density is nothing but the strength of what rate of flow of electric field around the particular source or particular point. And you have to make note down the relation as well. We'll be using it in the upcoming slides, derivations and laws. And magnetic field intensity is nothing but strength of the magnetic field around the source. And flux density, same, the rate of flow of magnetic field around the point. So what is epsilon naught and mu h? Epsilon is nothing but this is the expression for epsilon. It's nothing but its permittivity. Mu is nothing but its permeability. Okay, so permittivity will be dealing with electric field. So the ability of the electric field to enter into the substance is called as permittivity. So we have to know the ability of the electric field cannot be retained in all the substances. It cannot make its way into all the substances. So we must calculate it. So that's what is permeability. Permittivity. So mu is nothing but it is permeability. That is the ability of the magnetic field to enter into the substance. That is called as permeability. So permeability is one of the very important term in the application of MRA. So to get a clear image of the MRI when you go and take an MRI. Okay, so permeability concept will be behind that. So the ability of the magnetic field which is entering into the substance will be responsible for creating the images in MRI scan. Okay, so these are the four field quantities which are very, very important in electromagnetism. So next one is units and constants. So what are all the units and constants which is very important? Okay, so length, mass, time, current, and units meter, kilogram, second, ampere, and its abbreviations. So everything you must know. So not only the final equation I know, so I know the Coulomb's law. The final equation I know, so I know the Gauss law. No, we should not uh, get into the electromagnetism domain like that. So each and every term, each and every units, each and every abbreviations are very, very important in electromagnetism to get mapped with the concept and its applications. And next one is universal constant in electromagnetic model. So what are all the universal constants retaining or pertaining in electromagnetism? So first one is velocity of light, that is speed of light, and second one is permeability. So as I said, so permeability is a concept in a magnetic field where the ability of the magnetic field to enter into the substance. Permittivity is nothing but the ability of the electric field to enter into the substance. So these are all the three universal constants which you will be following in all the derivations of all the concepts. And next one is, we are moving into the one important concept in EMF. Okay, that is coordinate systems. Okay, so coordinate system is, how do we specify the direction of vector? Okay, we need to find the locations of anything. Okay, if you want to find the location of the truck, if you want to find the location of the plane, if you want to find the location of a particular person, you must need the knowledge on coordinate systems. That too, in a three-dimensional space, we are in need of three numbers. So coordinate system is a representation of point in space. On the whole, we can say like that. It describes a vector. It describes a vector component specific with a length, direction, and angles as well. Okay, so these numbers depend upon the choice of the coordinate system. So there are three coordinate systems available. Number one is Cartesian coordinates or rectangular coordinates. Second one is cylindrical coordinates, and third one is spherical coordinates. So particular coordinate system will be chosen only when a problem of a given geometry is analyzed. Okay, Cartesian, you can see the notations of the respective coordinates. Okay, so in a rectangular coordinates or Cartesian coordinates, you will be using x and y and z coordinate. Cylindrical, you will be finding an angle out there, phi, and one is radius and one is height, z. So spherical coordinates, you will be dealing with one radius component and two angle components. So there are various applications which needed coordinate systems in different methods. So according to that, we can change the coordinate systems from one coordinate system to another coordinate system and infuse it in our applications and solve the respective query. Okay, so applications of coordinate systems, you can refer the diagram. So we want to locate the air transport, that is a flight in the air. So coordinate system is very, very important in that aspects. Okay, so this work is done by air traffic controller. So air traffic controller's work is to locate the aircrafts in the sky. So by means of what he will locate the aircraft, it's only with the use of the coordinate systems. Okay, in order to describe the location of the aircraft, coordinates will be assigned to the each vehicles in the air, which is roaming in the air. So the air traffic controller must locate the particular locations, and he will assign the departure and also the arrival of the particular flight. So which results in proper landing and proper departure of the takeoff and take-in of the aircraft. So in many movies, we can also view this applications, but we do not know this is mapped with our domain EC, that is coordinate systems. So nowadays, all the movies which we are seeing in all the OTTs, they are connected with any one of the applications, but normal people won't be realizing that it has one applications. But we, the domain experts, right? So we are under electronics and communication. So we must know the particular application when we see any movies or when you see any pictures which are shown in the television. For example, this application is widely shown in the movie called Identity. You can go and see that movie. It's a Malayalam movie. So its name is Identity. So in that, in the before the climax, so the air traffic controller will dislocate the coordinate points, and he will ask the plane to uh, land, but the other plane will be ready at the respective location to take off. Okay, so at that time, the hero will switch off the transponder to safeguard all the passengers. So definitely, you must go and see this movie. The movie is called Identity. You can view the application of coordinate system state at the climax scene. At the flight scene, you can see. So according to the coordinate systems, he will he will decide to crash the planes, but another super concept called a transponder. With the help of a transponder, the hero will save the passengers uh, by switching off the transponders. Okay, so you must definitely see this and get some ideas on electromagnetism domain. Okay, next topic is so I hope you got some clear idea on what is a coordinate system. So next picture is, that is gradient. So gradient is nothing but you're going to find the slope. Okay, and it is a scalar field respect to positions, and it can also be a vector that it will point in the direction of the greatest rate of increase. Okay, so where there is a greatest rate of increase at a particular area, we are going to find the gradient part of it. So applications, for example, the temperature of all the points in the room, it is called as a scalar, right? So we have seen what is the basic laws of scalar, and we got some idea. So according to that, I mapped the application. So the temperature of all the points in the room is considered to be the scalar quantity. So gradient points in the greatest temperature of increase will be the vector. So where it is pointing the maximum rate of change, where the greatest temperature increase is going to happen, at that place the vector will come into play. Okay, so that's what is the applications of gradient. And another application is, you can see the diagram. So how gentle the land is, whether it is steep or whether it is gentle. Okay, so that also we can calculate based on the gradients points. So in the construction purpose, we can use this gradient and slope calculations for its accuracy or to avoid many accidents. Okay, next one is divergence. So divergence is the concept which makes it clear how the electric field and magnetic field behaves. Okay, so how a field behaves towards or away from a point. So that's what the divergence concept tells us. It relates the flow of a vector field through a surface to the divergence of the field within the volume. Okay, what is actually is that the volume integral will be equivalent. Okay, the volume integral of the divergence. So we are going to consider a volume. In that, how the field is going to diverge, how it's going to behave towards or away from the point. That is what the divergence concept tells us. So capital A dot product, divergence is nothing but it's going to be a dot product. Okay, dot product is a scalar product, and divergence of A is vector field, and it is going to convert from volume to surface as well. Okay, so divergence theorem is very important for the conversion of volume to the surface integrals. Okay, it is the magnitude will vary from point to point. Okay, it will vary from point to point, it can vary. Okay, so divergence is nothing but how the behavior of the field is going to be when it is around the point, when it is around the source, whether it is going to move towards or when it is moving toward, it's going to move away. So that's the concept under divergence. So next one, application of divergence. So these are all the applications. So clearly concentrate. So first application is building the structures. Okay, to check if the structure can handle different kinds of forces like wind or weight, etc. So so nowadays government projects are not that much accurate, but divergence concept must be infused in the building structures to check if it can hold the different kinds of forces. So when it is checked properly only, the building can withstand any kinds of winds, because natural calamity can destroy anything. So only the technical aspects or technological aspects can save us from natural calamities. So the result of what is the result? So we can safeguard our day-to-day life like this. We can infuse the concepts in the building structures. We can apply the technology and safeguard our life. So building structures. Okay, next one is fluid flow. That is how much water we can able to infuse it in the pipe. So that is also we can calculate with the help of the divergence. So we can calculate, because volume to surface. So how much volume a pipe can withstand, how much amount of water the surface can withstand. So that's what divergence will explain us. So next one is structural stress analysis in civil engineering. That is varying loads. One of the best example for this is bridge construction. Okay, so in bridge construction, every areas cannot have a construction of bridge. Okay, so engineers will check it. They will check the stress analysis using only divergence theorem, whether the area, that is the area, the particular area can withstand the loads. It can withstand the bridge weight or bridge weights. Okay, so such stress analysis will be done by the engineers, and then only we can construct any bridge in a particular area. So all the areas cannot be uh, used for the construction of the bridges. Okay, so next one is fluid flow analysis. As I said before, fluid flow. So optimizes the flow of water or oil. So how much water or oil can be loaded in the truck? It has to be calculated by the divergence theorem. Okay, so otherwise the truck will collapse, it will turn around. Okay, and accidents may happen. So everything has a calculations. So everything has a meaning in electromagnetics. Okay, so next one is curl. So curl is nothing but it's a special derivative of the vector field. So how an vector field circulates at a given point, that is going to be clearly said by curl operations. Okay, what is this circulation? You can clearly understand by looking on to the diagram which is shown at the bottom side. So the two diagrams. Okay, so it shows the rotations, right? So how the vector field circulates at a given point. Okay, so it is a rotational extent of the field about the point. So we are going to calculate the circulation density at each point of the field. So study of how fluid rotates and flux behaves. Fluid rotates means flux is also going to rotate at the same rotation. So we can calculate the electric flux as well, and we can also measure the spinning action as well. Okay, so whether the field is rotational or irrotational, we can calculate by using the curl operations. Okay, so cross product is nothing but curl. Dot product is nothing but it's a divergence. Make it clear and uh, understand the differences. Okay, curl is nothing but it's a vector. We are going to find the directions, right? So cross product. Divergence is dot. It's a scalar. Okay, so you can clearly understand by referring the two diagrams. So first diagram, rotation, arrow marks, it's rotating about the source point. Okay, so the right hand side diagram is, you can see the particle rotating around the curl vector. So the center point is a source and you are having the rotation. Okay, this is the curl vector at F at P point. Okay, so next one is, this is somewhat a generalized diagram of what is a gradient and what is a divergence and what is a curl. Okay, so gradient is nothing but it points to the maximum uh, instant. So which is maximum, I'm going to refer that. Okay, divergence is that it's going to move away or it's going to move towards the field. So that's what is clearly mentioned with the help of the arrow marks. Curl is nothing but you're going to have the rotations. Okay, Berling point, we will call it as, or circulation point, circulation theorem. So all the rotational aspects can be clearly mentioned by using the curl operations. So next one is Stokes theorem. So Stokes theorem is nothing but it's a fundamental theorem for curl operation. So we are going to make use of the cross product. So because it's a fundamental theorem for curl, so it is going to follow the rotation about the surface. So make it clear. So Stokes theorem, it's a fundamental theorem for the curl operation. So curl and Stokes. Okay, Stokes created a theorem by using the curl operations. Okay, so you're going to transfer surface integral to the line integral and vice versa. So Stokes theorem, it's a basic definition on Stokes theorem. The surface integral of the curl of the function over the surface is equal to the line integral. Okay, so C is nothing but your closed curve, F is a vector field, and surface. So line integral is converted to surface integral del cross F. So it is going to follow the curve path, that is rotations. So del cross F in the surface ds, differential surface. So every equation has a meaning. So you should not just like that study. Okay, you have to understand the meaning. Okay, so this equation, I'm going to explain it with the help of the diagram. Okay, so a girl is walking in the positive direction of C. Okay, C is nothing but here it is a closed curve according to the equation. Okay, so the girl is moving towards the C, that is closed surface. Okay, so she is going to have a relationship between the surface of the curve. She is going to follow the curve and also the surface along its direction. So that's what the Stokes theorem says. So C is nothing but your line integral and S is nothing but your surface integral. So she is moving along the line and she is following the curl, that is rotation, along the surface S. So this is what the equation says us. Okay, S is nothing but any surface bounded by the curve. So how the surface goes, how the curve follows, the girl is going to take that path. So that's what the Stokes theorem tells us. Okay. Next one is Coulomb's law. So the first Coulomb's law we are studying from the 12th standard itself, right? So the product of 2 point charges is proportional to the product of charge and inversely proportional to square of the distance between them. Definition all we know very well. So, but where we are using it? So we obey the Coulomb's law obeys the principle of superposition. What is superposition is one of the main concept in electromagnetism. Okay, so because in a field many charges will take place, not only one charge, right? So every charge will be creating an electric field, right? So the net result will be the vector sum of electric field due to individual charge. Okay, so every charges will be resulting in electric field, right? So so at the end result we will be summing up, we will be integrating it. That is what superposition theorem is. Okay, every charge will create a respective field. Summation of all the fields will give you the superposition result. Okay, so that's how we have to calculate a field strength. Okay, but every charge in the space will create an electric field. That electric field will be independent of the other charges. Okay, so one charge result will be independent, but on the whole we must calculate the superposition, that is all the resultant sum. So that's what is Coulomb's law follows. Okay, that's what it's inversely proportional to square of the distance. Distance plays a major role because like charges attract you, that concept. Okay, you have to make clear the concept. So distance plays the major role in Coulomb's law. Okay, next one is when you study the Coulomb's law, we must know the electric field intensity as well, because the force will exerted on a unit charge in an electric field, right? Electric field intensity is nothing but a charge will be present. So how much the strength of the electric field is, Okay, that's what is electric field intensity. So you can refer the formula. So F by Q. So charge will be experiencing a force which results in the high electric field, strong electric field, powerful electric field. So that's what is electric field intensity is all about. So when another charge is brought into this electric field, it experiences a force. Okay. So the field intensity exists everywhere in space, right? So field intensity is present. So that's how the application will be resulting in the reality, right? So field is the main concept. So next one is electric field intensity. Multiple charges. When multiple charges takes place, what will happen? So distance between them plays a major role, and permittivity also plays a major role. So that's why we have included the epsilon naught as well, right? So the ability of the electric field must be calculated. So electric field intensity results in the strongest electric field. So permittivity also plays a major role. Ability to enter into the substance. So ability of the E field to enter into the substance. So that's what is permittivity is all about. Okay. So next one is application of Coulomb's law. So very interesting concept. So day to day we are using this Xerox machine for taking a printout, for preparing spiral binding, or preparing any lab manuals, records, okay, observations, anything, even a content, we are taking a Xerox, we are taking a printouts, right? And we are using it. Okay, notes. While taking the notes also, nowadays students are very, they are not writing. They will just take the data in the pen drive. They will go to the shop. They will take the printout. So what is the application behind it? It's our domain application only. That is Coulomb's law. Okay. So the forces of attraction. So what is the concept behind the Xerox machine? It is Coulomb's law. You can boldly explain it. So all the very important technologies, helping hands technologies, helping hand applications is our domain. So I know about it. So you must be very proud to be an electronics engineer. Okay. So force of attraction. What is the concept behind it? Is that the force of attraction between the unlike charge or force of repulsion between the like charge, right? That is a concept, and the transfer of charges will be done due to them, which is used for printing the content in the paper. Okay, so force of attraction between the unlike charges, force of repulsion between the like charges. Okay, that is a basic concept behind the Xerox machine. Okay, so keep it in mind, Coulomb's law application is Xerox machine. Okay, so you can also, the students interested in electromagnetism domain can also bring some novelty in Coulomb's law applications as well. Okay, like some other extent work in a Xerox machine. Okay, so keep it in mind and work on it. Okay, next law is Gauss law. So Gauss law is, it relates the flux through the closed surface. Okay, you can refer the equation down there. So phi is equal to Q. So flux is equal to charge. Okay, so the total flux linked in the closed surface is equal to the total charge enclosed in that volume. So in a particular volume, how much charge is there? It is equivalent to the flux linkage in that particular surface. So flux is nothing but total amount of field. Okay, so whatever field it may be an electric field or it may be a magnetic field. Okay, so that is equivalent to phi is equal to Q. That's what is Gauss says us. Okay, next one is to apply the Gauss law. What are all the basic steps? Okay, first you have to define the surface. Okay, before moving out to any concepts or any laws in electromagnetism, we have to be clear on the selecting the surface first. On all the surface, we cannot implement any applications. Okay, so define a Gaussian surface, calculate the charge Q inside the surface, and calculate the flux displacement. Okay, so equate it and find the D. So D is equal to epsilon E, and hence the electric field intensity E. Okay, so epsilon E, you can find it from the D, and E is equal to, you have to vice versa it. Okay, you have to make it from E is equal to, okay, D divided by epsilon. And next one is one of the main applications of Gauss law, electric field due to an infinite long straight charged wire. Okay, you're taking a wire. Okay, you're going to that is charged, and you're going to, it is infinitely long as well. You're going to find the electric field in it. Okay, so on the entire wire, you're not going to find the electric field. You're going to take a part of it. Okay, so that's what is your first step. Consider a very small area ds on the surface. Okay, so whenever you're going to deal with any applications, you're not going to take as a whole. Okay, you're going to take as a part of it. You're going to first analyze it, infuse some laws, and equate it to the larger amount. So this is what is a smartest way of dealing with any applications. Okay, so when you approach any concepts or when you approach any applications, we have to first start from the little portion of it. We have to select a small area of it. Then only we must infuse it the big concepts and big areas. Okay, so same, first is you can see from the cylinder, charged wire. So electric flux through the curved surface. You have to calculate the flux. So electric field intensity and your ds. Okay, and phi is equal to integral part of E into ds. Integral is nothing but it is a summation of infinitesimal changes. That is your integration. So why we are going for integration is nothing but many changes will be happening in the field. So time to time it changes. So all the infinitesimal changes must be gathered and you have to produce the results. So for that we need to have an integration. Okay, so that's what is the, we have used the integration to for the calculation of flux. Okay, then you have to find the Gauss law concepts. Okay, E and ds are right angle. You can take it from the diagram, and then you have to calculate the total flux through the surface. Okay, this is some basic application only. Okay, not it's a complicated one. It's a basic. First you have to select a surface, Gaussian surface, then take a small part of it, calculate the flux and calculate the electric field intensity on that. Next one is magnetostatics. So magnetostatics, we know, so branch of electromagnetics dealing with the effect of electric charges in the motion. Okay, we are having a magnet, we are experiencing a force around it, which is called as magnetic field. So E field exerts the force on the stationary or moving charge. So magnetic field produced by moving charges. So steady magnetic cannot exert force on the stationary charge. That's why it's produced on the moving objects. Okay. Next one is Lorentz force. So Lorentz force is nothing but Lorentz is going to give us the relationship between electric field and magnetic field, both the fields. So that's how Lorentz has created the force. Okay, force acting on a particle, okay, along the space which contains both the electric field and magnetic field. So that's what is Lorentz has said. Okay, he has also termed as magnetic force is perpendicular to both the magnetic field and velocity. He followed the right hand rule as well. Okay, it's perpendicular to both the current and force. So he explained the theorem that in a particular field both the forces can happen and what are the changes that is experienced. Okay, so next one is Biot-Savart law. So Biot-Savart law is that magnetic field is produced due to a current carrying segment. Okay, that we know. So he gives the relationship between the current and the magnetic field. You can get it from the diagram. Okay, the direction of B field is perpendicular to the line of the element, right? So direction of B field is perpendicular to the line of the element, and thumb is pointing towards the current and other fields is pointing towards the magnetic field direction. So that's what is Biot-Savart law tells us. So magnetic flux density can be determined using the formula below. Okay, current, differential current element, and the radius. Okay, next one is importance. So using Biot-Savart law, what we are going to uh, uh, find. Okay, so it is similar to Coulomb's law. It is applicable for very small conductors. It is applicable for the symmetrical current distributions as well. Okay, symmetrical current distributions, we can infuse the Biot-Savart law. Okay, next is applications. So what are all the applications? You can calculate the magnetic responses. You can use it in the dynamic theory. Okay, changing theory to calculate the velocity induced by the vortex lines, that is to calculate the velocity aspects. Okay, vector. Next is magnetic induction at a point due to wire, and all the induction, magnetic induction concepts we can clearly derive with the help of the Biot-Savart law. Next one is Ampere's law. Ampere's law is also is going to give the relationship between a current and the magnetic field. Okay, so same diagram only, right? So you can follow the formula out here. So B dot dl mu naught into I. So Ampere's law also follows the right hand rule, and thumb will be pointing towards the electric current, and fingers curl around indicates the direction of magnetic field. So electric current will be equivalent to the magnetic field. Okay, what are all the magnetic field available? We are integrating and we are equating it to the electric current. Okay, and permeability also plays a major role. And next one is practical applications. So as we saw there, so similar applications. So how we are going to calculate the magnetic field due to the long straight wire. So you are going to consider a wire. So in that wire, how the magnetic field is created. So using the Ampere's law, we are going to create similarly how we are calculated the Biot-Savart law. Similarly, we are going to calculate the magnetic field due to long straight wire. So there, using Gauss law, I think we have calculated the electric field due to that wire. So here, magnetic field we are calculating. So that's what the difference is, E and B. Okay. And next one is practical application. So we are going to use the Ampere's law, and we are going to use the Biot-Savart law in the motors, generators, electromagnets, etc. So around it, magnetic field will be created, and it will lead to the working of the motors, electromagnets, generators, transformers, etc. And next one is inductance and capacitance. So capacitance, it's a charge storing element in the electric field. Inductance is in the magnetic field, right? And then reactance, what is reactance is that opposition of the flow of alternating current is called as a reactance. Okay, so time constant is nothing but total time. Okay, time taken for the element to respond, that is called as time constant. So all the basic parameters I have infused it, just you can refer it. Okay, so what are all the units? What is the formula? Okay, capacitance is the ability of the component to store an electric charge. Inductance means it is the ability of the component to store the magnetic energy in the magnetic field. So capacitance is all about in the electric, this is basic only. Okay, capacitance in the electric field, inductance is in the magnetic field. Okay. Next one is time varying fields. So time varying fields is nothing but I already explained it. So stationary charges, electrostatic field. Steady current, magnetostatic field. Time varying currents, we have to deal it with the electromagnetic field because it is changing from position and time. So only in a non-time varying case, E field and H field can be considered as the independent. Time in a time varying fields, that is in a dynamic conditions, they are interdependent. Okay, so changing electric field will change the magnetic field, and vice versa. So time varying currents are very, very important because it is going to change. So at that time, superposition theorem comes into play. So everything is interconnected. Okay. So next one is Maxwell's equation. So Maxwell, we have learned all the equations, right? Gauss law, Biot-Savart law, Ampere's law, Coulomb's law, Stokes theorem. So many laws I have created. So what are all the observations and what are all the understandings? Okay, the creation of electric and magnetic fields from the electric charges and current is given by the Maxwell's equation. Okay, you can refer it here. So the Maxwell's equation of electromagnetic theory. So first equation is about the Gauss law only. So charges will be making an electric field. Right, rho is nothing but your density. Okay, epsilon is permittivity. So every parameters you must know what is that. So what is the meaning behind that? You have to map it. So when you try to map it, and when you map it, you will be going into the next step of involving that components to the application. So that's what is your project about. Okay, first, without knowing the knowledge on the parameters and its theoretical aspects, you cannot map that particular topics and particular parameters in your applications, and you cannot frame a product. That is very, very difficult. So first step towards the project is nothing but you have to understand the basic parameters. Start from the basic parameters. Okay, so Gauss law, charge makes an electric field. So next one is magnetic field is solenoidal. Solenoidal is nothing but you are not going to have any divergence is that in that. So del dot B is going to be 0, no divergence. Okay, third one is Faraday's law of electromagnetic induction. That is, change in flux is going to induce the EMF. That's what is Faraday's law of electromagnetic induction all about. So electric field is going to rotate around the changing magnetic field. Okay, so next one is Ampere's law. So Ampere's law we have studied. So current will be making the magnetic field. It's perpendicular. Okay, so J is nothing but your density. That is called as displacement current as well. Okay, next one is boundary condition. So we have learned many things. Okay, so we have learned many theorems, we have learned many concepts, etc. But where that concept will stand strongly, that is very important. Okay, at what field, at which field the concepts or applications, what we have studied, what we have implemented, what we have derived must stand strongly. So for that, we have to know some boundary conditions. Okay, so solutions, because without knowing the boundary conditions, all the applications will collapse. All the applications or concepts which you're infusing to make the application success will be inaccurate, infinite, unstable, etc. So boundary conditions will describe the behavior of the electromagnetic field at the interfaces between the two medium. Okay, when you move from one medium to another medium, the field must satisfy some conditions. That is called as a boundary condition. Okay, for example, when you have a conductor, when you have a dielectric, dielectric is nothing but your non-conducting material, poor conductor of electricity. Okay, when you move from conductor to dielectric, so the parameters which I have mentioned here, E, D, B, H. Okay, electric field intensity, magnetic field intensity, electric flux density, magnetic flux density must satisfy some conditions at the interfaces to get success, to make the strength of electric field a very big success. Okay, for that, it must satisfy some boundary conditions. Okay, so that boundary conditions will be satisfied by the two components. Number one is tangential component and number two is normal component. Okay, that both components will be describing the behavior of the directions, that is vectors. Okay, tangential now field will be parallel to the surface. Normal is field will be perpendicular to the surface. So when it is parallel to the surface, what will happen to the parameters? What will be the electric field? What will be the magnetic field? When it is perpendicular to the surface, what will be the parameter nature? So that considerations you have to follow to make your assumptions and understandings to be successful. It is very, very important in electromagnetic wave propagations and in antenna design and also in compatibility issues. So one component is compatible. If it should be compatible, if it should be withstanding at the particular location without any failure, without any unstable components, it must satisfy the boundary conditions. That's it, the result is. So it is derived by applying the integral form of Maxwell's equation. Okay, that is Gauss law, Faraday's law, all the laws will be infused in it by using the tangential component. That is, field will be perpendicular to the surface and parallel to the surface. So like that, all the fields will be allocated and testing will be done. Okay, so these are all the boundary conditions. Both it can be done. For electric field also it will be calculated, and for the magnetic field also it will be evaluated for the success of the electric field and for the success of the applications we design. Okay, so thank you. So I hope I gave some insights on electromagnetism, and I wish all the students must kickstart their career on electromagnetism theory. They can kickstart whatever the domain they are interested, but my wish is electromagnetism and RF domain is very, very interesting domain. So many job vacancies and many research topics are under only electromagnetism. So I hope all the students will be taking this domain and working on this domain and creating many products, and they are going to service the society. Thank you so much.
Thank you, ma'am.
Sir, thank you, sir. Thank you, sir.
It was a very nice presentation. Actually, they are studying the EMF now in the current semester itself. So
Okay,
whatever
sir.
you
Okay,
followed
sir.
is for them nearly 2.5 minutes or near to 3 units. You covered the complete 3 units again. You
Yeah.
made a brush up of all the 3 units. It was a nice presentation, particularly the application areas which we were not able to cover in the
Yes,
classrooms.
sir. Yes, sir. Yes, sir.
That particular
We
application
are
of
not
curl
having time,
divergence.
sir, to. So here, thank you for you that I gave some insight to the students.
Sure, ma'am. Sure, ma'am. It was a very great insight for them.
Thank you, sir.
Manjunath, are you inside? Manjunath?
Yes, sir. Yes, sir.
Yeah, you can proceed. Before that, Tarun? Tarun is inside?
Sir,
Yeah, you proceed. Yeah, proceed, Tarun.
sir. Yes, sir. Sir, I have shared my screen, sir. It is visible, sir.
Yes, visible. You can proceed, ma. I think your voice is not audible, Tarun. Ma'am, for a token of appreciation, we are presenting this memento for your great presentation on this today's lecture, ma'am.
Thank you, sir. Thank you so much.
Thank you very much, ma'am. Thank you very much, ma'am. Manjunath, you can provide the vote of thanks. Manjunath, you can provide vote of thanks.
Yes, sir. Okay, sir. Can I continue, sir, right now?
Yeah, Manjunath, you continue with vote of thanks.
What are friends? A contextual enhancement webinar 2025 from Coulomb to Maxwell. Understanding core laws and conceptual of engineering electromagnetics. A very warm and pleasant evening to everyone. As we wrap up this insightful contextual enhancement webinar 2025, it's honored to express our heartfelt gratitude to everyone who made this session possible. First and foremost, a special thanks for our guest speaker, Sandhya, ME Ph.D. Assistant Professor, Sri Sairam Engineering College. Your deep knowledge and passion for the engineering electromagnetics have truly inspired us. This, the way of simplified the journey from Coulombs to Maxwell made us even the most complex concepts feel approachable and exciting. We are truly grateful for your time and dedication. We extend our sincere gratitude to our chief patrons, Dr. Sridharan, Chancellor, and Dr. Avik Shetty, Pro Chancellor, whose continued support and vision drive our institution towards the excellence. A heartfelt thanks to our patrons, Dr. S. Narayanan, Vice Chancellor, and Dr. V. Vasudevan Register, for always encouraging academic initiatives like this. Our appreciation also goes to our convention, Shishi Anand Sir, Vice President, and Arjun Kalasalingam, Vice President, whose leadership continues to inspire us to push up boundaries in this bright pool of knowledge. We are incredibly grateful to our Dean SCET of Dr. P. Shivakumar Sir and our event supportive HOD Sir, Dr. J. Charles Previn, for this constant motivation and guidance throughout the planning this of webinar. A special mention to our faculty coordinator, Dr. J. Prakash Sir. Your dedication, planning, and attention to this detail have been backbone of this event. To our student coordinators, Sri Raghav, Mannath, and Tarun Kumar, your hands-on work and our teamwork behind the census played a crucial role in the making of this webinar run smoothly. Your commitment is truly uncomfortable. Finally, a big thank to your participation for this achieve involvement, questions, and enthusiasm. Your curiosity and passion for learning made me this event vibrant and engaging. Let us carry forward today's knowledge, not just a theory, but inspiring to explore innovative and applying these concepts in a real world. Once again, thankful for making this webinar successful. Looking forward to many more learning journeys together. Have a wonderful evening. Thank you, sir.
Thank you all. Thank you very much, madam. Thank you for your valuable
Thank you,
time
sir.
to give the insights. Thank you. Thank you very
Thank
much.
you, sir. Thank you, sir. Thank you for the opportunity.
Yeah. Students, you can leave. Pa. Thank you.